I'm Dan from Factory Studios, and in this Unity tutorial, we're building a complete third-person aim system using Cinemachine 3.1.4 and the new Unity input system. You'll learn how to set up an aim camera with shoulder swapping, control zoom and camera smoothing, show a world space crosshair, and hook it all into player movement and input. This is a beginner to intermediate tutorial, but probably closer to intermediate. If you've got a basic third-person controller already, you're probably ready for this. All right, if you haven't seen the first video, start there. The link and starter Unity package are below. And if you're serious about mastering Unity, check out my full course, Unity 101 Game Dev Bootcamp. We build a full local multiplayer game from the ground up. It's fun, practical, and beginner friendly. You'll learn a lot. If you guys like tutorials like this, hit subscribe. I post Unity tutorials like this every week. Thanks. Let's look at what we'll be adding today. So we have our third-person free look camera. We have the ability to zoom in and out. And then we have a right click to aim with a reticle that shows where we're aiming, and the ability to strafe left and right, back and forth, and then the ability to shoulder swap. So we're going to add an aim camera rig using Cinemachine's ThirdPersonFollow. We'll create a system to switch between free look and aim views, and we'll add a world space crosshair with mouse and gamepad control, and we'll add support for shoulder swapping, like a true third-person shooter. Let's start by making sure our player is set up properly. So you should have a player and potentially with a capsule and a capsule collider on the player level. Let's delete the capsule and capsule collider from this level and make sure you have these components on your player game object. Then create a player underneath called player mesh. And this player mesh game object should have a capsule with a mesh filter, a mesh renderer, but no collider. Then under that, we have a nose. And actually, I'm going to remove the nose just by deleting it. And then I'll right click on player mesh and I'll go to 3D object and create a sphere. We're going to pull the sphere out on the Z axis and then move it up on the Y. Now I'll go into my project window. I'll right click on assets and go to create, select material. We'll call this mask. We'll drag our mask material onto the mask we created, which is called sphere. We'll update that to also reflect the name, mask. And then in our mask material, I will check off emission, set it to a somewhat white color, and that's it for the mask. And that should be it for the player and player mesh. Now this setup allows you to delete this entire mesh if you didn't want to use it anymore, and add your own player mesh. So if you had an animated character, you could drop that down here in place of player mesh. In order to get the animation working, you would have to connect the player controller to an animator on the player mesh, which is for another tutorial. In order to get our aim camera to work properly, the way I solved this was by using a yaw target and a pitch target. So we're going to right click on player and hit create empty. The first object will be called yaw target. Then we'll right click on the yaw target and we'll create empty again. And this will be called pitch target. Now that'll set us up for our aim camera rotation and movement. Okay, let's go ahead and add an aim camera. I'm going to right click in the hierarchy and I'll go to Cinemachine, Cinemachine camera. And I'll call this aim camera. Now under position control, I will select third person follow. This gives us the ability to set a camera with a shoulder offset and a camera side, which allows us to swap from one side to another. Now we need to set our tracking target. We'll set that equal to our pitch target. That aligns our camera properly. We'll move our camera shoulder offset up to 1 in the Y and 0.75 on the X. If you scrub camera side, you can see the camera will move from one side to another. You can adjust these values as you need for your game. Now we'll also set our damping to 0, 0, 0. So that there's no strange floating when we move. If you want to see your camera in the game view now, you can select this priority checkbox and change the value to 1. This assigns the aim camera as the active camera for Cinemachine. If you hit play, you'll see that it starts in the third-person camera. But if you change the value of your priority, you'll see Cinemachine does a smooth transition from one camera to another. Next, we'll create an object called Camera Manager. So right click in the hierarchy, hit create empty, and type camera manager. We'll move both cameras underneath the camera manager. So grab them and drag them on top of the camera manager, and they will become children of the camera manager game object. We can reset their location to 0, 0, 0, but it won't matter. Cinemachine will still manage the camera's positions. Next, we're going to update our input. So double click on player controls, and let's modify our input actions. So under gameplay, we're going to add an aim button. So let's right click and hit add action. We'll call this aim. Our first binding will be the right mouse button. So pull down the path, select mouse, select right button. We'll add a new binding, and our second binding will be the gamepad, right bumper. Next, we'll add a switch shoulder input. So right click, hit add action, and call it switch shoulder. This will also be a button, and under our first binding, we'll pull down path, hit V, and then we'll add a new binding. We'll pull down path, and we'll go to gamepad, and we'll go down until we see left trigger. Now you can save your asset, and before we move on, we're going to update our camera controls. Next, we'll add look under camera controls. So right click, hit add action, and call it look. Make sure it's set to value and vector 2. Drop down, select the first binding, and set that to mouse delta. Add a new binding and set it to gamepad right stick. Next, let's delete mouse zoom and gamepad zoom. Right click on each one and go to delete. Now right click and hit add action. We'll call this zoom. This will work for both gamepad and mouse. We want to make sure that we have our action type set to value and our control type set to axis. Delete the first binding. Create a new positive negative binding. We'll rename this to mouse. Expand that, and for negative we will go to mouse, scroll, and down. And for positive we'll go to mouse, scroll, up. Next we'll add another positive negative binding. This one will be gamepad. Expand that, and for negative select gamepad left shoulder. And for positive select gamepad right shoulder. Now let's save this asset and close it. You'll see a new error appears on player controls, camera control actions. We'll go to our third person camera, we'll scroll down, and when you find third person camera controller component, right click and select remove component. In your project window, go to scripts and delete third person camera controller. Now select your third person camera. With your third person camera selected, make sure to expand radial access. Set the range from 0.25 to 2.5. Go down to your Cinemachine input access controller and set your gain on orbital scale to -5 and your accel time to 0.25 and decel to 0.25. This gives you some easing in and out when zooming. The radial axis allows you to zoom without a script, which is what our third person camera controller did. To make sure gamepad works, under orbital scale, assign the zoom camera controls. Before testing, we have to switch our input actions to our custom defined input actions. So click the target on input action and find camera controls / zoom. Now we should be able to test and zoom with gamepad and mouse. This is mouse zoom and this is gamepad zoom. Next, we'll create an aim camera controller. So right click on scripts, go to create, mono behavior script, aim camera controller. Now let's open this script by double clicking on it. We'll start by creating a bunch of serialized fields. So this one will be a private transform yaw target. This is the target that we created under the player. The next one will be a serialized field, private transform, and this will be pitch target. Again, a child of the yaw target. Now we'll create a serialized field, private input action reference look input. This is a reference to our input action that deals with looking. Another serialized field, private input action reference. This will be switch shoulder input. So this is the button that will switch us from left to right shoulders. Then another serialized field, private float mouse sensitivity. We'll set this to 0.05 by default. And a serialized field, private float gamepad sensitivity. And we'll set this to, you know what, we'll set this to 0.5 float, 0.5. We'll see how that feels once we get in the game. Another serialized field, private, float, and this is the general sensitivity. So we can modify both the gamepad and the mouse separately, and then we can modify the overall sensitivity. Okay, another serialized field. This one will be a private float, pitch min. We'll set this equal to -40 degrees, and a serialized field private float, pitch max. And we'll set this equal to 80 degrees. So this is the amount we can look up and down. And another serialized field, private Cinemachine, ThirdPersonFollow. And this is our aim cam. And then finally, a serialized field, private float, shoulder switch speed. And we'll set this equal to 5. So this is the speed at which our shoulder switch happens. Now we just have some private fields, private float, yaw, private float pitch, and private float target camera side. So yaw and pitch have to do with the rotation of our camera, both on the horizontal and the vertical axis. All right, now we will define an awake method. Just start typing awake and then hit tab. In our awake, first we'll want a reference to our aim camera. So we'll say aim cam get component Cinemachine ThirdPerson Then we'll set our target side, target camera side, equal to our aim cam camera side. So this is just initializing our aim cam, this is initializing our target camera side to whatever our aim camera side is set to initially. So if we're initially set to the left side, then we'll start there. This ensures that there's a smooth transition the first time you switch shoulders. All right, now let's go to our start method. In our start method, we'll define a vector 3, we'll call it angles, and we will set it equal to yaw target dot rotation dot Euler angles. So this is our default yaw rotation, and we'll set our yaw equal to angles dot y, and our pitch equal to angles dot x. Now we'll set our look input asset, look input dot asset to enabled. This turns on our input from our player controls input action asset. Okay, now we'll create two new methods, an on enable. If you just start typing on enable, Visual Studio will recommend it. You just hit tab once you see it recommended. Now in on enable, we're going to call switch shoulder input dot action dot enable. So this will enable our switch shoulder input, and then we will set our switch shoulder input dot action dot performed to plus equal on switch shoulder. So this is a method that we will define, and we can just right click on this method, go to quick actions, and say generate method. And there, Visual Studio has created the method for us. Okay, now we're going to create an on disable. Just hit tab once you see Visual Studio recommend the on disable. And all we have to do here is copy this code from on enable, and instead of enabling, we're going to disable our input action, and instead of plus equal, we're going to minus equal on switch shoulder. So this will just unhook everything and turn off our input actions if this game object gets disabled. So now we can make our update method. So first thing we'll do is set a vector2 look equal to look input.action.read value vector2. So this will take our look input and set it equal to our look variable. And we'll say if mouse.current does not equal null, so our mouse is currently being used, and mouse.current.delta.is actuated, that is, the mouse is currently being used, then we'll set look times equals mouse sensitivity. So that will just multiply our look values that we just got from our look input by our mouse sensitivity. Now we want to do the same for our gamepad. So if gamepad.current does not equal null, and gamepad.current.right stick dot is actuated, then look times equals gamepad sensitivity. Now you can see that I'm referencing the right stick in code here, which means that it's no longer bound to our input actions asset. This is not the best implementation, but it will work for now. All right, so now we will set our yaw to plus equals look.x times our general sensitivity. We'll set our pitch equal to minus equals look.y times sensitivity. So we're doing minus equals so that we invert the up and down, which feels more natural when playing. Next, we'll set our yaw target dot rotation equal to quaternion dot Euler 0f yaw 0f. And then we'll set our pitch target dot local rotation equal to quaternion dot Euler pitch 0f 0f. Finally, we'll set our aim cam dot camera side equal to mathf dot lerp. This will smooth our position in our camera between our aim cam camera side, so that's our current camera side position, and our target camera side position. And we'll do that over time dot delta time times shoulder switch speed. So this essentially animates over frames a transition from our current camera side to our target camera side. Okay, now let's go back up here and set our switch shoulder method up properly. So we're going to say our target camera side equals our aim cam, so our current aim cam camera side, and then we'll make this a conditional. If it's less than 0.5, we want to set it to 1. Otherwise, we want to set it to 0. All right, let's save that and go back to Unity. Now inside Unity, we'll select our aim camera and we'll drag our aim camera controller in. And you can see we have some work to do here. So let's start assigning our references. The yaw target goes in the yaw target from the player to the camera. The pitch target also from the player to the camera. Our look input is something we set up already, so let's go in here and we'll find camera controls look. And then switch shoulder input also. Go in here and we'll find gameplay switch shoulder. And finally the aim cam really is just a reference to our Cinemachine camera. We can just drag our reference from our game object back in here. And everything else should be set up properly. Now if we wanted to test this in Unity, we could set its value to 2 and hit play. So now you can see we have the ability to rotate, look up and down. Our player still is not strafing, and it doesn't move relative to our camera position. All right, so next let's make a camera switcher so that we can switch easily between cameras. So right click on scripts, go to create, mono behavior. We'll call this camera switcher. We can select our camera manager and drag our camera switcher onto it. Double click on your camera switcher to open it. Now this script is going to listen for aim input. It's going to raise the aim camera's priority and then disable zoom input, and it's going to rotate the player to match the camera forward on exit. Okay, so let's start by defining some serialized fields. So the first one is a serialized field private Cinemachine camera, and it's going to be called free look cam. The next one, serialized field private Cinemachine camera again, and this one will be called aim cam. This is so we can switch between those two cameras. Next, we'll create a serialized field reference to a private Cinemachine input access controller. We'll call this input access controller. Okay, another serialized field, and we'll have a private reference to camera main camera. This is just our main camera. Next, we'll create a serialized field, which is a private reference to player controller, and we'll call it player. The next serialized field will be a private game object Crosshair. This we haven't created, but we will create it. Say Crosshair UI, and then a serialized field, private player controls, and we'll call that input. Then we'll have a private input action, aim action, and we'll create a private bool is aiming. We'll set that equal to false by default. Then a private transform yaw target and a private transform pitch target. Finally, a private aim camera controller, and we'll call it aim cam controller. Okay, a lot of private variables. Okay, next let's work on the start method. So in the start method, we are going to set our aim cam controller equal to our aim cam.get component aim camera controller. We'll set our yaw target equal to our player.transform.find yaw. You know what? I'm not going to do that. We'll set our input axis controller equal to our free look cam.get component, and then Cinemachine input axis controller. Finally, we will set our input equal to new player controls. Now this works as long as you've set your player controls to generate a C# class. We can look at that real quick. So with your player controls selected, make sure that generate C# class is checked off. And this allows you to create an instance of this class in any of your game object components. Okay, so then we'll do input.enable. That makes sure all of the input is enabled. Aim action equals input.gameplay.aim. And that's it for our start. Now in update, we will determine whether to switch camera states. Now update will define whether we need to switch from one camera to another. So let's start by defining a boolean. Bool aim pressed equals aim action dot is pressed. So if the user's pressing the aim action button, then this boolean will be true. Then we'll set player is aiming equal to aim pressed. Now we haven't defined player is aiming, so this is a property on our player controller. What we can do is click on it and then hit Control period, and we'll ask Visual Studio to create a property or a field for us in the player controller, and just hit enter. Now if you were to hit F12, this will jump you over to the player controller script, and you can see it's created an internal bool is aiming. We'll just go ahead and switch this to public and hit save and go back to camera switcher. Okay, next we'll say if aim pressed and not is aiming. So if somebody just pressed aim and we were not previously aiming, then we'll enter aim mode. Once again, we haven't created this method, so we'll hit Control period while we're on it, and we'll have Visual Studio create the method for us. Else if not aim pressed and is aiming. So we are currently aiming, but we let go of the aim button. Exit aim mode, and we'll go ahead and hit Control period on that to generate a new method. All right, so now we have two methods that need some logic. So we'll start with enter aim mode first. In enter aim mode, we'll first set is aiming equal to true. Then we'll set our aim cam dot priority equal to 20. And we'll set our free look cam dot priority equal to 10. So that'll switch cameras. We'll set our input axis controller dot enabled equal to false. So now the free look cam can no longer rotate. Okay, and now let's create the exit aim mode. So in here we'll set is aiming equal to false, and we'll set our aim cam dot priority equal to 10, and our free look cam dot priority equal to 20. It's just the opposite of what we've done before. And then our input axis controller dot enabled equals true. So we can control this camera again. Okay, now there are two things we want to do to clean up the transition between these cameras. The first thing is when we're entering aim mode, we want to snap our aim camera to our player forward. And that way our aim camera is not always looking off in a different direction. So we'll go ahead and create a new snap aim camera to player forward method. And again, I'll hit Control Period and let Visual Studio create the method for me. And in here, it's going to be pretty straightforward. We'll have an aim cam controller, and we'll call set yaw pitch from camera forward. To do this, we'll send in the free look cam.transform. Now this isn't a method that we've created on our aim camera controller. So again, we can have Visual Studio do its magic. We'll hit Control Period and we'll have it generate a method. Now if we hit F12, there's nothing going on in here. Okay, the first thing we're going to do here is change internal to public. I just prefer that. And we'll change this transform to camera transform so that it doesn't conflict with any. All right, so first we'll create a vector 3. We'll call it flat forward. We'll set it equal to camera transform dot forward. Next, we'll set our flat forward dot y equal to 0. And then we'll check if flat forward dot square magnitude is less than 0.001, then we'll return. So we don't want to continue in this method. Otherwise, our yaw will be equal to quaternion dot look rotation flat forward dot Euler angles dot y. And then our yaw target dot rotation will equal quaternion dot Euler 0f 0f yaw 0f. So this applies our yaw to our orbit pivots. Next we'll set our pitch target dot local rotation equal to quaternion dot Euler 0f 0f 0f. And this will reset our pitch to 0. So we won't modify the pitch, but we will modify the rotation. Essentially, this gets the rotation from our camera transform that we've sent in and aligns our yaw in our aim camera controller to the rotation of the incoming camera. In this case, our free look camera. So let's hit save. And now we can go back to camera switcher. Okay, so that deals with the snapping once we enter. Oops. So this should actually be on enter aim mode. So let's just select that line, hit Alt and down arrow key until you've got that line inside your enter aim mode method. Okay, in exit aim mode, we want to do something else. In exit aim mode, we will do snap free look behind player. So this will align the free look camera behind the player when we're exiting aim mode. Because again, the free look camera is not moving while we're moving in aim mode. So in here we will say Cinemachine orbital follow, and we'll create a new variable called orbital follow equals the free look cam.get component Cinemachine orbital follow. And then we will say vector 3 forward equals our aim cam dot transform dot forward, and float angle equals math. Here's some trigonometry for you if you've forgotten it. A tan 2 forward dot x forward dot z times math f dot rad to degrees. So we're essentially doing an atan function on the forward x and z and then multiplying that by rad to degrees. So this just multiplies our number to get a degree from a radian. So that ultimately turns our radian into a degree that we can get an angle from and then assign to our camera. So orbital follow dot horizontal axis dot value equals angle. And that should be it. So let's go back to Unity and see what we need to assign now. Okay, so select your camera manager and you can see there are a lot of assignments we need to put in here. So first we'll get the free look camera, which is really the third person camera. Then the aim camera. and we're looking for the input axis controller. This is on the free look camera or the third person cam. So let's drag that in there. Then our main camera is the main camera up here. And then our player clearly is the player. So we'll just drag that in there. And now Crosshair UI is something we haven't created yet. So let's right click in our hierarchy, go down to UI and select image. Now we'll call this Crosshair, and then we will select our canvas. We'll rename this to Crosshair UI, or maybe Crosshair UI canvas. And now in our canvas component, we want to set render mode to world space, and we want our event camera to be set to the main camera, and that should be it here. Next we'll go to Crosshair, and we'll set our width to 0.5 and our height to 0.5. We'll set our sprite to knob, and maybe we'll make it red, and that should be that. Now we don't need to worry about placing it right now, and we won't see it if we test, but we will create a controller for this that aligns the crosshair in the center of our screen space. But we want it in world space so that it can clip behind our player and any other object that's between our view and the UI. Okay, so what happens if we hit play now? Let's test. All right, if we right click, you can see there's a transition between the aim mode or the aim camera and the third person camera. And it's really slow and smooth. So let's see what happens if we speed up the transition. If you select your main camera and go down to default blend under the Cinemachine brain, I tested and I think 0.15 is a pretty good value. It happens pretty quickly. Now you can see that even though this works, the player is not rotating. We can't strafe. So the player controller needs to be updated to know when we're aiming so that can strafe. But we can still move in our third person mode and we can still jump. So we're making progress. All right, so let's update our player to strafe and move properly when we are aiming. So let's select our player. We'll double click on our player controller. So now we've already added the public bool is aiming. Now we just need to use that to modify the way we move and rotate. Okay, so we're going to modify the update method. The first thing we'll do is set a vector 3. We'll call it move direction like we had below. We'll set it equal to vector 3.0. So initially it's zeroed out. And we'll say if is aiming, and we'll grab all of this code and we will copy it in here. And then we'll say else, and we will copy the same code in again. Now we can copy this portion of this line into each of our if statements and then delete the line from down here. Okay, so the difference between these two move styles is whether we are moving relative to the camera or not. And in the case of aiming, we are not moving relative to the camera. We're just moving relative to the player's current direction. So we'll change camera transform to transform, and we'll leave this movement down here the same way, so that in third person we will move the same way we did before. Okay, now let's handle rotation. So this code here is what rotates us. We're going to do something similar. If is aiming. Okay, now for rotation we're going to need our yaw target, and we don't have that defined yet. So let's go ahead and add a new serialized field with a private transform yaw target, and now we can use this down in our rotation code. So in order to rotate, the first thing we'll do is we'll check if we are aiming or not. We'll create a vector 3 look direction, and we'll set it equal to yaw target dot forward. So then look direction dot y equals 0, so we'll just zero out our rotation on the y. If look direction dot square magnitude is greater than 0.01 f, then quaternion, our target rotation, equals quaternion dot look rotation look direction, and then transform dot rotation. This is assigning our actual rotation. Quaternion dot slurp. We want it to happen with a smooth transition. So from our current transform dot rotation to our target rotation, and over time.delta time times 10f. I've picked 10f arbitrarily, and it seems to be a good speed. So that's our aiming, and then we will do our regular rotation down here, which would be else, and actually we could just delete all of this and leave that intact. Okay, and then the last piece of code is our jumping, which has nothing to do with our camera direction or our aiming. Although you could, if you wanted to limit your player from jumping, you could move this out of the general scope of this method and put it into one of the sections where you're not aiming. Before we can test this, we need to assign the yaw target, which is this yaw target below the player. Make sure that it's assigned to the player controller, yaw target input field. Before we test, let's set our main camera blend speed, the default blend speed, to 0.15, otherwise we'll get a long blend between cameras. Okay, now by default it looks like we're in the player aim camera. Let's also update the priority on the cameras. So we'll just set both of them back to 0. We'll let Cinemachine deal with priorities. Okay, so now we should be able to hit play. Now you can see we're in a third person camera. I'll right click, and our player is rotating with the camera rotation. We're able to look up and down, rotate right and left. Good, and we can still do that in our free look camera, our third person camera, and then I'm going to try with the gamepad. So there's in our third person camera, and then if I hit the right shoulder, free look is working, we can look up and down, and we can move. And moving is strafing. Good, it looks like we have everything working properly so far. All right, the last thing we need to build is our world crosshair, so our UI crosshair. So what we're going to do is right click on scripts, go to create, select mono behavior script, and we'll call this world crosshair controller. We'll double click this to open, and as usual we'll create our serialized fields first. Serialized field, private, and this is going to be a rect transform. So UI elements or canvas elements have a different kind of transform than regular 3D elements. And the rect transform is essentially a 2D transform. So this is going to be called Crosshair UI. And we'll create another serialized field, and this one will be a private camera aim camera. Then we'll create another serialized field, and this will be private float max distance. We'll set that to 20 by default. Another serialized field, private float crosshair offset multiplier. And we'll set this equal to 0.01. And then we'll finally set one more serialized field. This will be private layer mask. We'll call it Raycast mask, and we'll set it equal to nothing right now. So, or everything. So the layer mask will allow us to mask out any objects we don't want our crosshair to hit. The crosshair offset multiplier will allow us to move the crosshair slightly off of any surface we're hitting so that as it aligns, it doesn't clip through. Max distance is the distance we want to shoot our ray. So beyond that, we won't really care about whether we're hitting anything. And clearly our aim camera is our aim camera. So let's go ahead and update our start method. So first thing we're going to do is set our cursor visible to false. And then we'll set our cursor lock state equal to cursor mode locked. If you're in Unity, you hit play, your cursor disappears, you can always hit escape, and that should bring your cursor back. All right, so now let's write in our update code. So first we're going to create a vector3 screen center. We'll set that equal to a new vector3 screen width. Let's see, screen dot width divided by 2. And that gives us half of our screen height, half of our screen width, and then screen height divided by 2. That gives us half of our screen height. And then finally 0. So that's going to give us a position in the middle of the screen. And then we will create a ray, and we'll set it equal to our aim camera dot screen point to ray. So we're going to send in our screen center to this ray so that we can shoot a ray directly from the center of our screen. We'll create a vector3 target position. This is where our crosshair will land, and we will say if physics dot raycast, and we'll send out a ray, the ray we've already defined. We'll say out raycast hit. That will return all of the places where our raycast hit. In this case, it'll return 1. There are different raycast methods if you want to get multiple raycast hits. And max distance and our raycast mask. So whatever we want to include in our hit check. All right, target position or target pause equals hit dot point plus hit dot normal times crosshair offset times crosshair offset multiplier. Okay, so that will give us a position based on where the raycast hit plus the hit normal direction. So if the surface is pointing up, it'll point up, and then we'll multiply that by a small fractional multiplier that will just move us slightly off the ground. Next, we want to set our crosshair UI dot rotation to equal quaternion dot look rotation hit dot normal. So this will set our crosshair to look in the same direction as our hit normal. Now normal is the direction of the surface that you're hitting. So you can imagine if you hit a surface that's facing you, the normal would be facing you. So if you rotated something to the same direction as that normal, it should be facing you. All right, and then just for debugging purposes in the editor, we can do debug, draw line, and then we'll start from the hit dot point to hit point plus hit dot normal times 2. So that gives us a line that should be 2 times the height of the normal, and then we'll make the line green. Okay, so that should settle that. Next, we want an else statement. And else, so this is if we don't hit anything, our target position is going to equal the ray dot get point max distance. So this will just be the max distance that the ray shot out to, and it didn't hit anything. And we'll set the crosshair UI forward equal to the aim camera dot transform dot forward. Okay, one last line and we're done. Crosshair UI dot position equals target pose. So let's go back into Unity and test all of this. So before we can test this, let's go ahead and drag our world crosshair controller onto our crosshair. And then we have some assignments to make. So our crosshair can be dragged in here. And again, these things that I've exposed here can also be grabbed in code. So you don't really have to expose them in the start or awake methods. You can always get the component. All right, so then we need an aim camera. So we'll just drag that in here. And actually, we really just want the main camera there. Okay, and then Raycast mask. So if we wanted to mask out our player, we'll need a layer for our player. So let's just go up to Layer UI, hit Add Layer, type Player for Layer 3, and then we'll go to our Player and drop down and select Player. And yes, we do want to change all the children. And then go back to your crosshair and drop down this Raycast mask again and uncheck Player. So just by clicking on it, it unchecks it. So we have everything else selected but the player. And it should say mixed now under Raycast mask. Okay, so now let's save this and let's hit play to test. I'm going to make this full screen by clicking on the Game tab. Now we can still rotate. I'm using the mouse. Jumping works. And then I'll hit right mouse button. And there we go. We have our crosshair. And you can see as we move off into the distance, the crosshair changes directions there. Okay, and just to make things more interesting, we'll add a couple of 3D objects. Now, this will only work with objects that have colliders on them. So you see the green lines. If the objects don't have colliders, then our cursor will not collide with them. Let's go ahead and make game full screen. So here we go. We're colliding with that smooth sphere, and you can see the crosshair is moving pretty nicely over that sphere. Now it's a little hard to tell with the box, maybe we're too far, but now you can tell that our crosshair is aligning to the box surface. And cylinders have a strange collider. They actually use a capsule collider, so you'll see as you move up and down, the crosshair will disappear. But there you go. Now you have a working camera system, which is third person and has an aim capability with a crosshair that aligns to environmental objects. You could certainly use that crosshair hit position to fire off projectiles. All right, I hope you enjoy this tutorial. Awesome job. You've now got a functional third-person aim system with shoulder swap, zoom, and reticle tracking. It's a great foundation for combat, targeting, or tactical movement systems, and so much more. If you want to learn how to build a full local multiplayer game, complete with combat, respawns, camera shake, and more, grab the Unity 101 Bootcamp course linked below. If you guys like tutorials like this, hit subscribe. I post Unity tutorials like this every week. Thanks. And share your progress. I'd love to see it. All right, thanks for watching, and I'll see you in the next tutorial.